Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be covering section 7.4 on our series on operations on fractions, multiplying, dividing, adding, and subtracting. We're going to be looking at how to divide fractions in this presentation. A sample problem we're going to be covering is given here. Find the quotients of the two fractions. The prerequisite skill for this tutorial is multiplying fractions. If you have forgotten how to multiply fractions or you need to brush up, you can just scan this QR code right here and we'll go over the review lesson so that you can be able to master this tutorial. Don't forget we have some practice problems at the end for you to try out to demonstrate mastery of the contents that we are covering. Alright, to get us started, we're going to go over the steps that are going to guide our problem solving process for dividing fractions. So let's go ahead and write down the steps. So when you're dividing fractions, the first thing you want to do is you're going to keep the first fraction. You have to ensure that they're both fractions, okay? If you have a mixed number, you have to convert that into an improper fraction. So they have to be both fractions first, okay? So assuming you're given two fractions to divide, as you see in this video, first thing is you keep the first fraction. The first fraction is called the multiplier fraction, just FYI, all right? So you keep the first fraction, and then the next step is you change the operation, okay? Change the operation. The original operation is division, so you change the division operation to what? You change the division operation into multiplication. We're going to go over why why you do that later on, okay? So keep the first fraction, change the division operation into multiplication, and then next you flip the second fraction. Flip the second fraction, okay? Another word for that is you reciprocate. When you flip, the denominator goes to the numerator position and the numerator number goes to the denominator position, all right? Flip the second fraction. The second fraction is also known as your multiplicand. Both of them together form your factors, all right? After you keep, change, flip, you then multiply the two fractions using the procedure that we covered in section 7-1. If you need to review that, as indicated earlier, just scan this QR code real quick and you'll be able to go right to that tutorial. And then you simplify or reduce your answer, okay? Simplify or reduce, they mean exactly the same thing. Now there's an acronym that is used for helping people remember how to divide fractions, and it's just done by keeping track of the first letters of the first three steps here, okay? So you have keep, change, flip. All right, so keep that in mind. Keep, change, flip. Some people refer to it as drop, change, flip. Is exactly the same thing. All right, so that's the order that you execute. So the acronym for the steps in summary or in short is basically K for keep, C for change, and then F for flip. All right, this is KCF, is not KFC. Okay, so this is KCF, keep, change, flip. So we're going to be referring to that in this video. We just say, oh, we're going to keep, change, flip. And when I refer to that sequence of steps, is just what we outlined here that we're going to be using over and over again to do the problems. Okay, so let's go ahead and attack some problems. All right, so the instructions are for us to find the quotient, of the given fractions, okay? So just remember that the word quotient is just a fancy word for divide. Number one, let's say we have 3/7 divided by 2/3. All right, let's take a look at how to divide these two fractions. So we have the first fraction, a multiplier. divided by the second fraction, the multiplicand. Bam, bam. All right, so we're going to use the keep, change, flip procedure. So how does that work? So the first fraction, this 3 over 7, your multiplier, you're going to keep that one, okay? So what does that mean? We're just going to keep it, we'll drop it down, 3 over 7. That remains unchanged. And then the operation, the division operation, you're going to change that. You're going to change it into a multiply. Okay? So you keep change, the division becomes a multiplication. And then the second fraction, or your multiplicand, is flipped. Okay? You flip this one. Alright? So when you flip that, that becomes 3 over 2. So that's what we mean by flip. It reciprocates. The number on the bottom goes to the top, and the number on the top goes to the bottom. Alright, so you see why it's important that they're all fractions when you're dividing, so you can carry out this keep, change, flip procedure. Alright, so you might wonder, why are we doing this? Why we keep changing and flipping? Well, you have to remember what division is. Division is the same thing as multiplying the reciprocal. Okay, so just to illustrate on a side note, if you are asked what is 4 divided by 2, it's easy, right? 4 divided by 2 is just 2. But another way you can do this is you can take 4 and multiply it by the reciprocal of 2, 2 over 1, which is 1/2. 4 times 1/2 is 4 over 2, which is just 2. The same thing. So don't forget, division is the same thing as multiplying the reciprocal. Okay, so that's what we're doing here. We're just multiplying the multiplier by the reciprocal of the multiplicand, and that is exactly what division is. All right, so now that we've done the KCF procedure, keep, change, flip, we're just going to multiply using the formula that we used. We went over in section 7.1. You multiply numerator by numerator, and then denominator times denominator. Bam, bam, across. And then your answer, you get 9 over 14. Now we're going to see if we can simplify. Are there any common factors? Some of you can just determine the answer by inspection, but let's show you the steps for doing that. So you just try and see if there are any common factors. These numbers are easy to break down. So let's break down the smaller one first, 3 and 9. Those are the factors of 9. And then we're going to look for the factors of 14 up to 9. All right, so what goes into 14? 2, since it's even. 3, no. 4, no. 5, no. 6, absolutely not. 7. 8. 8 doesn't go. 9, nope. So we can just stop right here. All right. If you notice, there are no common factors here. So what does that tell us? It tells us that we are done. Okay. So let's write down our final statement. 3 over 7 divided by 2/3 is equal to 9 over 14. Ladies and gentlemen, that is the answer to question number 1. All right, let's move on. All right, so for question number 2, we have 2, let's say we have 2 over 5 divided by 13 over 10. All right, let's do that. All right, so let's copy down the two fractions. 2 over 5 divided by 13 over 10. So what we're going to do is follow exactly the same set of procedures that we did for number 1. We're going to keep, change, flip, okay? So we already have it done in step number 1, so we're going to just apply it here. So we keep the first one, 2 over 5. We're going to change the operation to multiplication, and we're going to flip the multiplicand to 10 over 13. All right? So step 1, you keep change, step 1, 2, 3, you keep, change, flip. Then you multiply, all right? Numerator times numerator, 2 times 10 divided by denominator times denominator. 2 times 10 is 20. 5 times 13 is 50 plus 15, which is 65. Now, are there any common factors that we can use to reduce this fraction? Let's go ahead and list out the factors of both of them, see if there are any common factors that we can divide out by. Start with the smaller one. What goes into 20? 2, 4, 5, 6, 7, 8, 9, 10, and 20. 65, factors of 65 up to 20. What goes into 65? 5 definitely, since it ends in 5 or 0. 6, 7, 8, 9, 13. And then 65. That's basically it. Are there any factors in common? Yes, we have one factor, which is the greatest, since it's the only one. So when we divide by 5, it's going to give us the completely reduced form. All right, so if we divide both sides by the greatest common factor, remember that you will always end up with the completely reduced state. If you reduce by smaller fractions, you still have to keep on reducing. All right, so since we divided by the greatest common factor, we're going to have 20 divided by 5 is 4. 65 divided by 5 is 13. So let's go ahead and write down what our answer is for question number 2. 2 over 5 divided by 13 over 10 is 4/13. 4 over 13. Bam. That goes your answer to question number 2. All right, problem 3. Let's take a look at something that looks a little bit different. What if you have a situation like this? 3 over 4 divided by 6. Okay, now we're dividing a fraction by a whole number. Remember, it was indicated earlier that you have to have 2 fractions if you want to divide. They have to be fractions first, right? So we have 3 over 4. This is clearly a fraction divided by 6, which is not a fraction, is a whole number. But guess what? All whole numbers are fractions. Okay? So how do you write a whole number in fraction form? You just divide it by 1. Okay? That is how you convert whole numbers to fractions. Just simply divide them by 1. Okay? All right, so we have 2 fractions now. We're good to go. So just keep the first one, change the operation to times, and flip the second number, the multiplicand, 1 over 6. Keep, change, flip, multiply across, top times top, 3 times 1, over bottom times bottom, 4 times 6, and then you get 3 over 24. Can we reduce this? Are there any common factors that those 2 numbers have? So for 3, the only factor of 3 is 3, and then 24. 2 is a factor, 3 is a factor. Stop right there because you already met the biggest factor of 3, which is 3. You can exceed the smaller of the 2, okay? So you stop right here. Oh, they're both common, so you can clearly see that 3 is a common factor. In fact, it is the greatest common factor. So if we divide by 3, we're going to arrive at the reduced form, the simplest form. So divide by 3, top and bottom. Bam, bam. And then you are going to get 1 over 8. 3 divided by 3 is unity, is 1. 24 divided by 3 is 8. Okay? So 3 over 4 divided by 6 is equal to 1 over 8. That goes the answer to question number 3. All right, moving along, number 4. So let's say for number 4 you have 2 over 5 divided by 3 over 11. Okay. So this is nice. We have 2 fractions here, 2 over 5, that we're dividing by each other. Just use the keep, change, flip procedure. Keep the multiplier 2 over 5, or drop it. Change the division to a times. We're going to be multiplying the multiplier by the reciprocal of the multiplicand. So we flip this, right? 11 over 3. Bam, bam. Now multiply across, top times top, over bottom times bottom. That's how you multiply fractions. 2 times 11 is 22. 5 times, oh snap, that's not 13, that's 3. 5 times 3 is 15. 22 over 15. All right. So in this particular case, can we reduce? Are there any common factors that these two numbers have? Let's see if there are common factors that we can reduce by. So we have 15. Do the smaller one first. What goes into 15? 3, 5, and 15. And then for 22, 2 goes 4, 5, 6, 7, 8, 9, 10, 11, and then 22. There are no common factors. All right, so this is the simplest form. But if you notice, this fraction is improper. So we also have to express it as a mixed number. So to do that, remember 22 over 15 just basically means you're dividing, just basically means you're dividing 22 by 15. Okay, so 22 divided by 15. So what we're gonna do is use long division. That's how you convert improper fraction into mixed numbers. All right. So the top number, the top dog goes in the doghouse. So that's 22, and then 15 is outside. Long division. How many times does 15 go into 22? If you look at your multiples of 15, you have 15 times 1 is 15, 15 times 2 is 30, 15 times 3 is, we already exceeded 22, so it's going to be somewhere here, okay? So the smallest, the biggest factor of 15 that's smaller than 22 is 15. So it's going to be ones, okay, because 15 times 1 is 15. So how many 15s can you get in 22? Is one whole 15. They're going to be remainders. So the steps for long division, you divide, subtract. Divide, multiply, subtract, bring down, right? So divide first, you get 1. We're now going to multiply. 1 times 15. Subtract that. There's nothing to bring down, okay? And this number here, this remainder, is smaller than your divisor, so we're done, okay? So this is now going to become the quotient, and you have the remainder over the divisor. Bam. There goes your answer right there. So let's go ahead and write down our answer statement. 2 over 5 divided by 3 over 11 can be written in two forms, and its improper fraction state is 22 over 15, or in its mixed number state is one whole number, 7 over 15. Bam, bam, bam. That goes the answer to question number 4. All right, let's take a look at one more problem, a word problem, and then I will give you some practice problems to try out. All right, question number 5. Consider the following problem. So Jack is a baker, okay? So Jack needs to make spicy muffins, okay? And has a total, and has 12 red bell peppers. So that's what he's going to be putting in each muffin. All right. So he has 12 red bell peppers. If it takes 1/4 of a bell pepper for each muffin, for each spicy muffin, question: how many muffins can he make? That's the question. Okay. All right. So let's go ahead and solve this problem. All right. So the formula that we're going to use here, the formula is as follows. So we're looking for the quantity of muffins to make. So the quantity of muffins that he's going to make is going to be the total amount of total amounts divided by unit amounts. Okay, total amount divided by, like that blue, unit amount. So let's adapt this formula to this particular scenario that we're dealing with. All right, so quantity that we need in this case is number of muffins. Number of muffins is going to be the total amount of pepper total amount of pepper divided by what? The total amount of pepper divided by the unit amount. What's the unit amount of pepper? When I say unit amount, for each muffin, how much pepper do you need? Right? In this problem, we're told that for each muffin, you need a quarter of a bell pepper. So this is the unit amount right here. Here is the total this is the total amount, and this is the unit amount. So total amount of pepper divided by the unit amount. All right, so in this particular problem, number of muffins is going to be the total amount of pepper, which is 12, divided by the unit amount, how much pepper you need for each muffin, which is 1/4. So how do you do this? This looks horrible, it looks scary. 12 over 1/4. So you just write, this is known as the vertical or the stacked way of writing division. So you just write it horizontally, okay? So what are we looking at there? This is the same thing as 12 divided by 1/4. Bam. There you go. Okay? So this is a problem we're going to be solving. What is 12 divided by 1/4? And that will give us the answer to the problem. So 12 divided by 1/4, we're going to follow exactly the same procedure that we discussed throughout this presentation. 12 divided by 1/4, first of all, make sure that they're both fractions. This is a whole number. Write it in its fraction form over 1. Okay. Keep. You drop the multiplier. Change the division to a multiply and flip the multiplicand. Keep, change, flip. Bam, bam, bam. Multiply top times top, bottom times bottom. Bam. 12 times 4 is 48 divided by 1, which is just 48. Okay, so let's go ahead and write down our concluding statement. Jack will be able to make what? 48 spicy muffins. All right, so there you have it. Okay, so it's now your turn to do some practice problems. Alrighty, ladies and gentlemen, so these are the practice problems that we'd like you to try out. So go ahead and pause the video presentation at this time and try out these 5 practice problems. When you're done, click on the playback button and we're going to review what the answers are for you. Alrighty, so here are the correct answers. Go ahead and check your answers at this time. So how did you do? If you did well on these practice problems, go ahead and destroy the like button for us. If you have any questions about these solutions or the problems we went over in the presentation, specify your questions in the comment section below and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. Don't forget to help support our channel by liking, subscribing, and sharing this video with your friends. Tons of support resources can be found at Mathgotserved.com or in the links in the description below. Thanks again for watching. We'll see you in the next video. Goodbye.